Hello, welcome to Management Science Studio. I'm Vahid Lotfi and I'm an Emeritus Professor of Management Science. In this video, I'm going to demonstrate how to solve the production planning problem or aggregate planning problem using different heuristics. Let's start by defining the problem. A single item multi-period production planning problem involves determining the minimum cost production schedule for a single part or a product to be produced over multiple planning periods such as weeks, months, or quarters. The production environment may be subject to limited capacity or production capacity may be unlimited. Various cost structures or sources are considered in determining the optimum production schedule. They are regular time production cost per unit, overtime production cost per unit, subcontracting cost per unit, inventory holding or carrying cost per unit per time period, a stockout or shortage cost per unit per time period, setup cost per setup, other costs such as hiring and or firing cost. It should be noted that not all of the above cost components may be present in every situation. Also, the above cost components may vary from period to period. The problem can be solved using various heuristics or via linear programming formulation, including the transportation model. In this video, I will demonstrate two such heuristic procedures, and in part B, I will illustrate the linear programming approach. So let's take a look at the heuristic rules. First, chase strategy or demand chase strategy. In the chase strategy, we adjust the production output to match the period demand. In this strategy, workforce levels are increased or decreased as needed based on the demand forecast. Hence, there will be hiring and or firing cost. There will not be any inventory carrying cost. However, if the production is subject to limited capacity, there can be shortage or stockout cost. The chase strategy or the demand chase strategy avoids underproduction and overproduction. Another approach or heuristic is called level production strategy. In the level production strategy, the production level in every period is the same and is equal to the average demand. In this strategy, there will not be hiring and or firing costs. However, there can be inventory carrying costs as well as stockout costs. So let's take a look at an example. A firm is about to develop its production schedule for the next 4 quarters. The production manager has obtained relevant data consisting of the demand forecast, regular time production cost, unit inventory carrying cost or per quarter, and setup cost for each of the next 4 quarters as shown below. The production capacity is unlimited. Overtime and subcontracting are not permitted. So we have the 4 quarters. Quarter 1, quarter 2, quarter 3, quarter 4. Demand forecasts are 100, 120, 130, and 150 units per quarter. Regular production costs per units are the same over the 4 quarters and it's $10 per unit. Holding cost per unit per period is $2 and it's the same for all 4 quarters. However, the setup costs vary. Setup cost in the first quarter is 200, for quarters 2 and 3 are 300, then for quarter 4 is 200. And as said above, no overtime, subcontracting or stockouts are permitted. And we are going to assume there is no capacity limit. So let's look at some heuristic solution procedures. I have prepared this worksheet in order to demonstrate the solution procedure. Data resides here, the original problem data with the 4 quarters, demands, regular time production cost, holding cost, and setup cost. Here, when I solve the problem, I am going to just record the total cost associated with each of the solution procedures. In this area here, I will show how to solve the problem. First, I'm going to demonstrate what happens if we actually produce all of the total demands in just the first period. So my chart is the 4 quarters. The next is the demand forecast. The total demand is the summation of these, which is 500 units. Average demand is 500 divided by 4, which is 125. We are assuming unlimited production capacity or infinity. In this area, I will type in the production amounts, followed by inventory, beginning inventory, end inventory, and lastly, the cost, the various costs, which are production, setup, and holding costs, and the total cost. So let's go ahead and get started. Let's say if I wanted, this is just for the purpose of demonstration. If I wanted to produce all of the 500 units in the very first period, I'll incur just one setup cost, but inventory carrying cost. My beginning inventory is 0. The end inventory is going to be the production amount plus the beginning inventory, which is 0, minus the demand. So we can see that we have 400 units at the end of the first period. We go to the second period, and so there's going to be 0 production in the second period, 0 production in the third period, 0 production in the fourth period. The beginning inventory of the next period is equal to end inventory of the previous period. This way, I can just copy the formula all the way across. The end inventory is going to be the formula that I put here, so I can just copy it and go all the way across. So in the second period, our beginning inventory is 400, which was the end inventory of the previous one. There is no production. Demand is 120 minus 400. We end with 280 units at the end of the second period. Similarly, in the third period, our beginning inventory is 280 from the previous period, and the demand is 130. 200 minus 130, we end up with 150 units, which is going to be the beginning inventory of the fourth period, and that is equal to the demand. Therefore, the end inventory is going to be 0. Now I can just determine the various costs. The production cost in the first one is going to be the production cost per unit multiplied to the total production. In this case, it's going to be the production amount, which is 500, multiplied to 10. I'm just going to put it here and make it an absolute cell and enter, and that's my production cost. And I can just copy this formula over, and we can see that I get 0 production cost in the next 3 periods. The setup cost in the first period is going to be equal to the setup cost in the first period, which is $200. There are no other setups, so I'll just type in 0, 0, and 0 here. Now we go to the holding cost. The holding cost is going to be equal to, we're just going to use the end period inventory amount, which is this which is going to be 400 in the first period, multiplied to our inventory carrying cost, which is the same. So I'm just going to make it an absolute cell reference and copy this over to the other 3 cells. And we can see for period 2, the end inventory was 280 units at $2 a unit, and that is a total of $560 in inventory cost for the second period. Now I can just do my total cost. So this is going to be the sum of these 3 cost components, and I can just copy that across. Now I can just determine the total cost and compare them. So this is going to be equal to the sum of these 4 costs, and we can just compare that with the sum of these rows just to be sure our formulas are right. And if I copy this formula all the way down, and we can see that 5,000 plus 200 plus 1660 is equal to $6,860. And that is going to be the total cost associated with producing everything in the first period, incurring one setup cost, but then carrying inventory all the way to the other one. I'm going to record the total costs in here so that we can later compare them. It's $6,860. Now let's go ahead and see how the level production strategy works. So for the level production strategy, we're going to produce in every period the average amount, which is 125, 125, 125, and 125. So similarly with the above process, we look at the beginning inventory. The end inventory is going to be the beginning inventory plus the production amount minus the demand, and we can go ahead and use the beginning inventory in this cell, which is equal to end inventory of the previous cell, and we can copy the formula all the way here, and we can copy the formula here, and you can see that for the level production we produce 125 units in the first period. We are left with the end inventory of 25 plus the production of 125 in the second period is 150. Our usage was just 120, or the demand was 120, so we end up with 30 units. 30 units plus 125 is 155, and the demand is 135, so we end with 25 units at the end of the third period, and 25 plus 125 is 150, which is our demand forecast for the fourth period. So the end inventory is 0. Now we can do the cost calculation. So production cost is going to be equal to the production amount multiplied to the production cost per unit, which was $10. I'm just going to type that in and then copy that over. We are setting up in every period, and the setup cost in the first period, let's take a look, is equal to 200. So we enter that. The setup cost in the second period is equal to 300. Third period is equal to 300. Fourth period is equal to 200. So those are our setup costs. Let's go down. Now we can do the holding cost. The holding cost, if you recall, per unit per period was just $2. So this is going to equal to the end inventory multiplied to $2, and we can just copy these formulas here, and now we can do the total. So this is equal to the sum of these numbers here, and we'll just copy that. And if we do the sum of the total cost of the 4 periods, we are going to get the total cost for the level production strategy, $6,160, which I am going to just type here, $6,160. We can see that the production cost using the level production strategy, the total is going to be much less than the total cost if we just did one setup, because our inventory carrying cost is going to be much less. We can take a look at the production cost. This is equal to the sum of these 4 numbers. The production costs are all going to be the same. The setup cost is going to be, however, much larger because we are setting up in every period. So that's almost $1,000, and the inventory carrying cost in this case is going to be 160 compared to 200, compared to 1,660 in the previous format. Now let's take a look at the demand chase strategy. Let's go ahead to this part of the spreadsheet, and we're going to use the demand chase strategy, which means that in every period, the amount of production is going to be the same as the demand forecast. So for period 1, I will get 100. For period 2 is 120. 3 is 130. And for period 4 is 150. Now with the same thing, we'll do the beginning inventory, end inventory, and so on. So the beginning inventory, the first one is 0. The end inventory is going to be equal to beginning inventory plus the production amount minus the demand forecast. And the next period, beginning inventory is equal to end inventory of the previous period. And we can copy this formula over and copy this formula over. We can see that because we are producing according to the demand chase strategy, which is the production amounts are exactly equal to the demand forecast, we have no inventory whatsoever. So now let's figure out the total cost associated with this approach. Production cost is going to be the same as before, which is the amount produced multiplied to $10 per unit, and we're just going to carry this forward. Setup cost, we're going to type in our setup cost as before. The first period was $200. The second one was $300. The third one was $300. Fourth one was $200. The holding costs are all going to be 0, but I'll just go ahead and do the formula anyway. It's multiplied to 2. And we can copy these formulas here and now do the sum. So this is equal to the sum of production, holding, and setup cost, and copy the formula to these cells and then do the total. So this is going to be equal to the sum of these 4 numbers. And the amount is $6,000. Let's compare with the other approaches. So this is going to be $6,000. So we have solved this problem 3 different really heuristics. The first one was just one setup and ended up with $6,850. The second one was level production and ended up with $6,160. And when we use the demand chase strategy, the total cost is equal to $6,000. We do not know for a fact that in fact this is the least total cost amount associated with the production schedule, because these are all heuristics. So in part 2, I'm going to solve the same problem, but this time I'm going to use a linear programming formulation approach.